Alright, let's get into it. So, this is my individual final project for CRT26004. So, first of all, let's get into static versus non-static methods. Static methods call upon the class object without making a new instance. They can only read other static variables and create blueprints to be called upon in the program. In the case below, the location objects are created and can be called upon using non-static methods. So we see, obviously the most obvious thing is that it says static below it, but the other thing you might notice is that there is nothing being called upon here. We don't see, for example, over here, get locations or other things like that. You see locations equals new locations, rows, columns. So we're creating and then initializing all the values in this array, in this 2D array. So that's the first thing we notice. Now with non-static arrays, it says created from that they are created from the instance of a class. They cannot directly read class variables, must make new instance of a class, and you can see from the example below that they are calling upon things that have already been created. So for example, if we were to call upon location after this has been initialized, we'll do get locations and they would all be empty. So assuming we were going to then set them to something, we would still have to call upon them from a static variable. So the static is over here, and when this is where things are set, and then the non-static calls upon those things and is able to manipulate that information. Similarly, we have game Pioneer Trail get current game, where you notice that it's calling upon something that's already been created. So we're creating an instance of a class. We're not directly calling upon the static variable, we're making an instance of that class and then doing something with that. Similarly, if we look down here, we have display inventory view, which allows us to make a new inventory view, so make a new instance of inventory view in order to display it. So moving on, we're going to now talk a little bit about arrays, array lists, and enums. So arrays are basically containers for information. In the image we see a two-dimensional array, which allows for grid storage. Each point in an array can be accessed by an index number as shown below, or index of numbers, because we can have multiples, as you can see here and here. So there's a for loop here, which we'll go into in a moment, but let's first look over here at the assign scenes to locations method, which is also static. So we'll notice that, first of all, row and column are obviously represented as R and C, and there's an enum reference right there, which we'll also talk about for Tundra. Now, as you notice, 0 and 0 gives us this position right here, which is 10. So 10 is 0, 0, and that is scene type Tundra, which we'll, again, like I said, we'll talk about in a moment. So we take the enum value of Tundra, which gives us 10, and we can do things with that. So we set the scene at 0 and 0 as 10. So we set that as the scene. And then move on through and set multiple things. So that's, there are multiple ways you can obviously work with a 2D array, a 3D array, but we'll talk about them a bit more. So in the example down here, we have a one-dimensional array, which is for answers. Now, in the way that we have implemented it in our game, we currently only have 2 answers to each question. But the idea was that this could be changed. So one scene could have three answers, for example, and one could have 2 or so forth. So we have here however many answers, which is counter. Counter is however many answers there are, and this for loop, which goes through them and moves the values into the answers section. So we created a bunch of string arrays and passed in variables. So we had a number of string arrays and then passed them all into this one method, which did all of it at once. So rather than having hundreds of extra lines of code, we consolidated it into a few smaller steps. So we have here this for loop, which takes this integer of I, which starts at 0, and increments it each time this runs through these steps. So for each time this runs through the steps, or gets to the end of the statement, it comes back around and increments and then tries again. and it will continue to do that as long as I is less than counter. Now, counter, in most instances, like I said, is 2. So it would first of all come through, grab the, in this case, the 0th value, the value at answer array 0, and give that to answer text. And then it would, answer text would be put into set answer for this one. And then result of answer would come from that string, and then health would come in from that. Again, some of these features are not completely implemented, but we have them in so that they can be displayed. So another type of for loop is used more often and a lot more frequently with array lists, and I'll talk about that again in a minute. But we can do it here as well, where the array of answer, as you can see it here, and that also works for array lists. So you could array or array list right here, is put here. This is the incremented value, so answer is the incremented value. So that would be, again, what I is. So that's another, you could put I there and I there and it'd be the same thing. And then answers is the variable, so answers is the variable. So it increments through every variable of answers in answer and puts this output. So that's another way of doing the same thing. You would obviously have more lines of text, but this is a different thing because this is getting the answer, whereas this is setting. But that shows you that you can be dynamic with how you do a for loop with arrays. And you'll also notice here that we have a static value up here and a non-static one down here where we're getting question and getting answers. So when we're fetching information about something is often because we're in a non-static. But also if you look here, we're fetching the value here in a static. And so that shows you that you can also fetch values in a static from a non-static, in a non-static way. So an array list is a way of making a dynamic array. So array lists don't need to have a specified size because they can be changed and modified as you go. So for example, I have here an array list of actors. Now the list is a little bit longer, but I decided to use a shortened version of it here because these are the player actors that were supposed to walk around on the journey. So each actor in the array is added a lot easier, as you'll notice here. If you go back to the previous page, let's go back for a second, you'll notice that set answer, set result, and set player health are in 3 separate lines, whereas here you could do it all in one line. So you could simply have put answer, result, health, all on the same line, and it would have been a lot shorter. And see, the benefit of this is it's a dynamic way of accessing information, but also it's a good way, for example, to have a list that empties out. So for example, an inventory, where inventory items might be there 1 minute and gone the next, whereas places on a map are probably not going to do that. So we have again this for loop. Now these 2 examples of code are not my code. They're from Static Overflow, or I can't remember the name of the site for some reason, but it is a developer's website where you can ask questions and get answers. And so I've used some of their code examples to give some of my demonstrations, not to pass it off as my own. The one thing I wanted to pass off, or to talk about, was this here, where position equals alphabet list index of H. So I didn't have as many places of array list in my own code, and so I wanted to talk about some examples here as things you can do with an array list. So the position here, if we were to use this in our instances, let's say we wanted to find out about Ralph the dog. We would write down position, so the index position, which is this number here, by the way. I put that, and that's an optional number that was added. But the index number or position of Ralph would be position equals actors dot index of, and then you would put Ralph, and that would return 2. And then you would have the position for him, and you can get information about him that way. Now another thing is, you'll notice that this for loop, like I said before, is the same as with just 2D arrays. So the array list car, which is where we had our array from earlier, and then using the variable of car, and then C is incremented. So similarly, if we go back, we have answer, answer, answers. Now that can be obviously confusing using very similar words, but this is our array, or array list. This is our incremented value, and this is the variable that we passed in, which is here. So this would have been that one there. This car here is the same as that one there, and then this one is what increments. So answer is what increments. So each time this runs through, answer increments by 1. So it'll start at 0 and it'll increment through until you run out of answers to increment through. So now let's talk about enums. So again, we talked about this a minute ago, but Tundra is the 10th point on the enum list. So enums, another name for enums, I suppose, would be constants. They're variables, or they're values that do not change. So there are two different ways, a couple of different ways that we can do an enum. We have a simple enum list, which is like this, where you simply put them down with no values, and there's ones that you can add multiple values to. So if you were to add multiple values to this, you could have actually many more. You could have description, you could have elevation, maybe just an integer or something. You could have a double for temperature, I don't know, but you could have multiple values, and the way you would add them to it would be you would have the quotations, then a comma right after that second quotation, then you would have the next value, then the comma, second last value, then close the bracket, and then the comma. So you would obviously have to specify them here, and then you would have all your values in your enum, and you could grab them much like you have here. So like I was saying a moment ago, you can grab information about an enum for using their position here. So right now, scene type planes ordinal meaning the number in this list, and in this case returns 10 for Tundra, or for planes returns the second value, or I guess 1, seeing as we start on 0. So in that position where planes is, return an integer, which is the index. So that index can then be used for setting things within that scene. So we have the scene 0 equals new scene, set index to that so that we have an actual value of index and so forth. Similarly, we can use it to, like with array values, see for example you have a row and a column. We saw that on the other page, and Indian camp was right there. That was 21, I believe. Yep, 21. So 21 is Indian camp, and then so we set the scene of the 21st scene in that location. So now for throw and catch. So in this case, this was used in our code when we were trying to save reports. I wrote this code and implemented it so that it could be used for any form of reports that come into it. So basically the report will come in as a string variable, or a string value, and you would have a second string which was the file name. So the first thing we do is find out if the file path is null. If it is, throw an exception and tell the user that there was an error with the file path. Next, check if there is an extension on the file path. If I was to put in log, let's say I wanted to have a log and I wrote in the word log, if there was no file extension, it would add .txt to it so that we would be able to read it in a program. After that, it takes that file path and the output and puts the output into this print stream and prints to that file path which it's created. So it checks to see if that was able to happen, and if it could not happen, it says that there was an error and gives you a exception code to it, and then closes the file. So let's talk more about the different types of output files. So another type of output file is saved games, which we'll talk about in just a minute, which are a form of byte stream. Character stream are files that can be read by the user because they're saved so that they can be read. They're read character by character, which is best for log files and reports. Whereas byte files are designed to be read not by the user. An example of this is a save game file. Bytestream is read by byte. I can't read my own writing. And this image comes from this website down below. So let's get into some examples. First of all, let me show you that there is absolutely nothing up my sleeve. I have an end file there, which is for our demonstration later, but I have no files here other than that I can draw from. So let's open our program, and you can see here, save your game. So let's pretend we're running through the save your game function. So if I press S to save my game, it will take me to this, tell me to save my game, and then go to save game view display. So let's go there, save game view display. Please enter the file of your save. I would write down my file name. It would then send me to game control save game. Under game control save game, we are here. We grab the game variable and we take the file path. So first of all, again, we do that same check where we check if the file path is null. And if it's null, then we say the game could not be saved. If it isn't null and there is no file extension, we add one. And then we try to output the file. Now you notice that it's simply out.writeObject, and then there's game. So game is written to the external file, file output stream, and then we check it to see if that was successful. So let's run through and actually see if we can make this work. So let's write down our name. My name is Steve, and I want to make a new game. So right now, let's look at the map. We are currently up here in town. Now we want to get down here. This is where the end of the game is. I have a saving right here in the hills, so I'm going to move to here. Let's move southwest. Let's press southwest, and then we'll save it and load it. So let's take the... Okay, you find yourself in a dense forest. There are two paths before you, one to the right, the other to your left. The left trail has a fresh set of footprints. The other appears to be overgrown. You take the right path or take the left. I'm going to take the right path. Seems less traveled. The path is windy at first, but you soon make it to the remains of an old campsite. Searching briefly, you find a spare wheel. Now we do not have the inventory fully implemented at the moment, so that is not something that's currently added, but the bare bones of it are there to be added to the player's inventory. Likewise, we do not have gather resources or repair wagon set to currently work, but everything else seems to work relatively well. So let's save our game right now. Let's save it to Steve, since my name is Steve, and we won't leave a file extension just to show that that does work. So if I press enter, game saves successfully at Steve. So let me drag over that folder again, and we can see Steve. There it is right there. The time is the same as what's in the bottom corner, and so I think we're done. So if I was to load a game, let's load my other game, or load that game even. Let's quit this game and just prove that that works. So let's play again. Steve again. Resume existing game, and we just type Steve, and we should be able to look at the map and see ourselves, yes, right there in the forest. So let's go back and load the other game, because I don't want to have to reveal the entire map for you. I will, but I didn't want to spoil the surprise. So let's load end. I called it end because it's right at the end. So let's go to the map. As you can see, I've already made my way across the map to here. So I can just go south and be in Zion. So congratulations, you have won the game. Dance or sing. Let's dance. Your family dances with joy. Now I know it comes to the game menu, but if you try to do anything, let's say view inventory, game over, start new game, restart an existing game, or quit the game. So the game is over, the game is complete, and that's all there is to it. Anyway, I hope this has been an interesting and informative video. Thanks for watching, and thanks for the great semester. See you later.